Hello, my amazing students. I am ready to do your 5.3 video, which is about applications of systems of linear equations, which means we're going to do some word problems. So we're going to start to talk about how to solve them, how to make equations that are going to be representative of the information in the problems, how to weed out non-essential information, things like that. The first problem that we're going to do, I will read to you. It says, in May 2008, MySpace and Facebook had a total of 96 billion page views. If MySpace had 5.2 billion fewer page views, how many page views did each website have that month? So here's the problem before you so that you have it in writing. And we're going to start with MySpace and Facebook had a total of 96 billion page views. So these are our two equations. Notice that they said that MySpace had 5.2 billion fewer page views. What they were insinuating is that MySpace had 5.2 billion fewer than Facebook. So this is the way that we would represent that. Anytime it's 5.2 fewer, it's going to be Facebook minus 5.2 billion is the MySpace. So now I'm showing that I'm using this equation, MySpace plus Facebook is 96, being 96 billion, and I'm going to substitute the MySpace from the second equation into this one, which means that F minus 5.2 is going to be substituted in where the M was originally for MySpace. And then I'm going to add the plus Facebook to get the 96 billion total. Now I have 2F because this parenthesis does not need to be here anymore. There's nothing over here for me to distribute. Twice Facebook, take away 5.2 is 96. I will add 5.2 to both sides. Remember to line up your decimal when you're adding numbers. So that's going to be 101.2. And then on the left, this cancels out. So now I just have twice Facebook. And then I'm going to divide 101.2 by 2, which is going to give me 5, 10, bring down my 1, and I'm going to end up getting 0, and then bring down my 2, and get a 6. So 50.6 is going to give me the half of 101.2. Therefore, divide by 2, divide by 2, Facebook is 50.6, and then MySpace, going back to this equation right here, MySpace is Facebook, which is 50.6, take away 5.2, and if I subtract 5.2 here, I'm going to get 45.4 is MySpace. So if I add the Facebook, which was 50.6, and the MySpace, which was 45.4, I will get 95. And then I need to carry over, so it will be 96. 96.00, which is what we were supposed to have. So let me pan out so you can see the whole solution, and that is problem 1. So problem 2 says, the Harold family purchased a rectangular lot on which they will build a new house. The lot is 40 feet wider than its length, and the perimeter is 400 feet. Find the length and the width of the lot. So here is the written problem, just so that you can see it. Trying to get it all there on one page. we're going to start with a rectangular lot, and the lot is 40 feet wider than its length, and the perimeter is 400 feet. So here's my picture of this problem, and this one is going to be set up very nicely for substitution, because we know that perimeter is twice length plus twice width. Okay, that's our equation for perimeter. We also know that perimeter is 400, and I have labeled this one L and this one W. So we know that this is going to be twice L plus twice W. But they've given us a relationship between our width and our length. And we know that our width is 40 feet wider than our length. Therefore, we can say width is length plus 40. And then we can take this width and substitute it in here. But before I do that, wouldn't it be nice if I were able to simplify this and make it a less complicated equation? And I can do that just by dividing the whole thing on both sides by a 2. So we can divide by 2, divide by 2, divide by 2, and get 200 equals L plus W. And now I go in to put in my new substitution here, and I get 200 is equal to L plus, and now my W is going to be L plus 40. Okay, so now 200 is equal to, now there's no reason for me to keep this parenthesis here, so I'm just going to get rid of that parenthesis and say L plus 40, or 2L plus 40. So I'm going to solve for the L. So I'm going to subtract the 40 from both sides, and I'm going to get minus 40 minus 40, 160 is equal to twice L, or L is 80. Okay, so we can go up here and say L is 80. And then we can say, well, if L is 80, then the width was 40 feet wider than 80, which means the width will be 120. And then I should check to see if these two dimensions comply with all the regs of the problem here. And we already figured out this one using the 40 feet wider, but then we should go to the perimeter and check. Twice the length would be 160, and twice the width would be 240. And if I add the 160 and the 240, I do get the 400 that was originally specified. And that is problem number 2. Problem number 3 says Tim bought 4 tickets to a Kenny Chesney concert and 3 tickets for a Jimmy Buffett concert for $334. Faith bought 2 tickets to see the Kenny Chesney concert and 5 tickets to see the Jimmy Buffett concert for $293. Find the cost of a ticket to each concert. Okay, so they're already telling you pretty much how to set up these two equations, so let's just go and write them down. Okay, here's the problem so that you can see it in writing. Okay, I'm going to solve these with elimination, and when we're eliminating a variable, we want one of our variables to be canceled out completely. So let's take the second equation and multiply by a -2, because that's going to give me a -4 here, which will cancel my 4 above it. So I'll have a -4c. So let's multiply the -2 all the way across. We get a -4c, and then a -2 times a 5b is a -10b is equal to 293 times 2. It's going to be a negative 6, 18, and 5. So negative 586. And then this one right here, I'm just going to copy down the first equation so that it's right here where I need it. And then when I add those together, I cancel my C's and I'm left with negative 7b is, and remember when we're adding opposite signs, this is a plus, this is a minus, we actually subtract the two numbers. So when I subtract 6 and 4, I get a 2, 8 minus 3 is 5, and 5 minus 3 is 2. But the result is negative because I take the sign of the greater valued absolute value. And I'm going to divide by a negative 7 and divide by a negative 7 to get B, the Jimmy Buffett tickets, would be 252 divided by 7 because my negative signs will cancel out here. 7 into 25 is going to go 3 times. 21, 42. So 7 and 42 is 6. So they are 36 tickets apiece. So I found one of the tickets. So now I have to go back to one of my original equations. So I'm going to go back to this one right here. Okay, I'm going to go back to 2c plus 5b, but instead of the b, I'm going to plug in my 36 because I'm trying to find out how much the Kenny Chesney tickets are now, is 293. So now when I multiply 6 times 5, I get 30, carry my 3, that's going to be 180. When I multiply that together, and I get 2c plus 180 is 293. And then I subtract the 180, and I subtract the 180, and I end up getting 2c, this cancels, is equal to 311. Okay, so I divide by 2, I divide by 2, and I wind up with c is equal to 113 divided by 2. 2 into 11 goes 5, 10, 1, and then that's going to be 3, is going to be 6, and 50. So 56.50, those are quite expensive. Okay, so now I used the second equation to find my value for C. So I really, to be sure, should go to the other equation and plug in both my C and my B and check. So I go up here to the very first equation and I'm going to plug in for the C 56.50, and for the B I'm going to plug in the 36, and I'm going to multiply it out to verify that it is indeed 4 times this amount plus 3 times this amount is 334, and it works. So I'll leave that for you to do. And that is the end of problem number 3. All right, so now we're going to do problem number 4, which is going to be a mixture problem. How many ounces of a 30% alcohol solution and how many ounces of a 50% alcohol solution must be mixed to get 100 ounces of a 42% alcohol solution? So I'm going to let you see the problem, and then we're going to talk about the steps of a mixture problem. Okay, there's the problem on the page in words. I always can understand things better when I see them in words. Okay, so here's a picture of our situation. we don't know how much of the 30% and how much of the 50% that we're going to have to pour into this beaker. But we want 100%, we want 42%, and we want 100 ounces of it. So we have an amount equation and we have a concentration equation. So our amount says that we have X amount of 30% and Y amount of 50%, and they're going to combine to give me 100 ounces of this mixture. So there's my amount equation. And then this is the concentration, or how much acid we have. I know you've heard the garbage in, garbage out that we use a lot of times with computers, but this is acid in, acid out, okay? When you're looking at this situation, no matter what amount that is, that X amount, we have 30% times X is the actual amount of acid in that beaker. Okay, 50% times Y is the amount of acid in this beaker. And they have to combine to give me 42% times 100 is the amount of acid in our final solution. So this is your concentration, or how much acid you have going into the situation and how much acid you want coming out. So now these are very nice to set up with substitution. So we're going to do this one with substitution. However, the very first thing we're going to do is get rid of all these decimals. So I'm going to multiply by 100, multiply by 100, and multiply by 100 to clear all those decimals out. And then I'm going to solve this top equation for X. I could solve it for X or Y, but X is going to be 100 minus Y, and I'm going to substitute that into this second equation. So my second equation now has 30 instead of 0.30, and I'm going to leave this little parenthesis where the X is going to go, plus 50Y is equal to 4200 when I multiply those together. So now I'm going to slide, instead of the X, I'm going to slide my other equation that has been solved for X. And now I have, when I distribute, 3,000 minus 30Y plus 50Y equals 4,200. Okay, so I'm going to subtract the 3,000 from both sides. So minus 3,000 and minus 3,000. That's going to cancel. This is going to leave me with 1,200. And then I've got a negative 30Y and a positive 50Y, which will give me 20Y. So now I'm going to divide both sides by 20. And Y is going to be 60. Because my zeros will cancel out when I divide. And 120 divided by 2 is 60. So Y is 60. So I'm going to go back up here and say Y is 60. But if Y is 60 in this first equation, that means that X is going to have to be 40. So my X amount is 40. Okay, so I used this equation here to find my value for X. Therefore, I should go back into this other equation and plug both of the values in to check and make sure that that one works as well. And these are the correct answers because I have the correct answers in front of me. So, but you should always take that last step. The last one we're going to do on this video is a distance, rate, time problem. It says a freight train and a passenger train leave cities 300 miles apart and travel toward each other. The freight train is traveling 20 miles per hour slower than the passenger train. Find the speed of each train if they pass each other after 3 hours. And so here's a picture of the problem. Okay, there's your problem right there. All right, so I always like to draw a picture of the situation. Now this is a picture of our word problem. We have a freight train leaving from one city, and we have a passenger train leaving from another city, and the two trains are traveling toward each other, and they are 300 miles apart. So they give us this little piece of information that the freight train is 20 miles slower than the passenger train. And we also know that they're 300 miles apart, so they were going to meet each other after 3 hours. They were going to pass each other after 3 hours. So, we know that distance is rate times time. That's a physics problem that we should be, formula that we should be aware of. Now, I'm a big chart person, so you will often see me make charts like this. I'm trying to get the glare off of this chart. My lighting is not so great. But I have distance, rate, time, and I have the freight train is going to be going 3 hours before he meets the passenger train. He's traveling at a rate of passenger train take away 20. We don't know what that is. But distance is rate times time. So I multiply the rate and the time together to get this one right here. So let me see if I can get the glare off. Can you see that? I don't know why it's glaring so much. Right? So distance is 3 times passenger minus 20 for the freight train. Then we do the same thing for the passenger train. It is going at a rate of P for passenger train, and it's traveling for 3 hours before it meets the other train. And so it is going, distance is rate times time, so it is going 3P. Now we know that together these two distances have to add up to give us 300. So there's our equation. 3 times passenger minus 20 plus 3 times passenger gives us 300. Now I just divided the whole thing by 3 to make it a little bit easier. And then we have passenger minus 20 plus passenger is 100. So then I copied that equation up here at the top of this next board, and then I went ahead and added my 2 P's together to get 2P, and then I added the 20 to both sides to get twice P was 120. So P, or the speed of the passenger train, was 60. If the speed of the passenger train was 60, we know that the freight train was 20 miles per hour slower, so it had to be 40. Okay, so we have 60 and 40, and then they traveled for 3 hours and crossed each other. So then I checked it. After 3 hours, the passenger train would have gone 60 times 3, or 180 miles. The freight train would have gone 40 times 3, or 120 miles, and together they went 300 miles, which satisfies the requirements of our problem. And this is Mrs. A, and may God bless your day. That's the end of chapter 5.3.